Bueno, buenos días a todos y a todas y bienvenidos a la Universidad de Alicante y a este acto de inauguración del primer Congreso Internacional de Inteligencia Artificial Educativa. Para mí es un placer enorme presidir este acto junto con mis compañeros, la profesora Rosabel Roig y el profesor Miguel Cazorla, que son, como todos ustedes saben, codirectores de este Congreso. Bien, pues comenzamos. Tiene la palabra, en primer lugar, el profesor Miguel Cazorla, codirector del Congreso. Miguel, cuando quieras.
Muchas gracias. Voy a empezar diciendo unas palabras en inglés para todas las personas que tenemos online. Good morning, dear Rector of the University of Alicante, Director of the UNESCO Chair, Rosabel Roig, colleagues and friends. It is both an honor and a privilege to stand before you today at the opening of this International Congress on Educational Artificial Intelligence. On behalf of the organizing committee, I would like to extend my deepest gratitude to the University of Alicante for allowing us to host this event in their facilities. Your support and collaboration have been instrumental in bringing this Congress to life. We are thrilled to welcome more than 600 participants, many of whom are joining us virtually from all corners of the globe. This remarkable turnout underscores the shared passion and commitment of the international community to advancing the intersection of education and artificial intelligence. This Congress is more than just a gathering. It is a platform to exchange ideas, inspire innovation, and explore solutions to some of the most pressing challenges of our time. Together, we will delve into the transformative potential of AI in reshaping the future of education, while ensuring it remains inclusive, equitable, and ethical. Let us embark on these days of insightful discussions, fruitful collaborations, and new connection with open minds and a shared vision for progress. Once again, thank you for being here, and welcome to what promises to be an extraordinary event. Thank you.
Tiene a continuación la palabra la profesora Rosabel Roig, codirectora del Congreso.
Muchas gracias, querido rector en funciones, querido profesor Miguel Cazorla, coordinador de ICEAI, queridos asistentes, ponentes. Para mí es un honor y un privilegio estar en esta inauguración, y digo por qué. Nosotros, tanto desde el grupo de investigación ROBIT como el nuestro de HIDU EduTIKIN, iniciamos una andadura en torno a lo que era la inteligencia artificial y cualquier aspecto relacionado con la misma o, en definitiva, tecnologías emergentes. Y iniciamos ese camino y, bueno, lo estamos recorriendo. Y creo que hoy es un punto importante, porque celebramos un congreso internacional. De hecho, es el primer congreso internacional que tiene como nombre tal palabra, tal concepto como es el de inteligencia artificial educativa. Y yo creo que esto marca un punto, porque es cierto que la inteligencia artificial, y más los de informática lo sabéis, ya hace mucho tiempo que está en torno a lo que es el conocimiento, pero vincularla de forma como se ha hecho desde, yo creo, 2022, cuando empieza ChatGPT, es una andadura que empieza ahora y sobre la cual podemos reflexionar, investigar, debatir, opinar. Y en ese mundo, dos ámbitos como es el educativo, por el que respecta a nuestra parte, o el informático, yo creo que pueden confluir en un camino común y empezar a construir lo que entendemos y lo que consideramos que debe ser la inteligencia artificial educativa. Por eso decía al principio que es un honor y un privilegio estar en esta primera edición, porque con ella empezamos un camino, yo creo que fundamental en lo que es la educación de nuestro siglo, ¿no? Yo también creo, y así se ha visto, este congreso nace a partir de un proyecto Prometeo, MEBAI. Prácticamente, y lo digo sinceramente, no hemos hecho difusión del congreso, es que ni lo he lanzado por las listas que tenemos, porque veíamos que de repente llegamos a más de 660 inscritos en un congreso que, como decía, no habíamos hecho apenas difusión. Y es que es un tema que interesa. En ese sentido, yo sí que quiero agradecer a todas las personas que se han inscrito. Es cierto que entre modalidad online y presencial La gente continúa prefiriendo la modalidad online, a todos los que nos están viendo por video streaming, los centenares, saludo. Yo sí que les invitaría a que en la siguiente edición pudieran asistir aquí presencialmente, porque aunque hablemos de tecnología, cuando hay una parte humana, presencial, yo creo que aporta siempre un valor añadido a todo lo que podamos hablar de qué queremos en torno a la inteligencia artificial educativa. Así que invito a los que nos están viendo a través de la red, invito a todos los presentes a que en la próxima edición también puedan asistir. Yo creo que hoy empezamos un camino con ponentes que han venido de la Universidad de Sorbona, la Universidad Central de Florida, vendrá mañana también Maripaz Prendes de la Universidad de Murcia. Podemos conformar en definitiva una red vinculada a la Universidad de Alicante y en ese sentido agradezco desde la institución, en este caso a Juan Mora como representante, todo el apoyo que siempre hemos tenido en todas aquellas acciones y actividades que hemos hecho y, como decía, creo que juntos podemos continuar y empezar este camino que hoy con ICEAI 2024 plantamos, diría yo, ese primer paso importante. Muchas gracias.
Gracias, Rosabel. Codirectores del Congreso, profesores Roig y Cazorla, miembros del comité organizador, ponentes, investigadores e investigadoras, señoras y señores. Siempre es un placer enorme y una enorme satisfacción para la Universidad de Alicante albergar eventos científicos como este que nos ocupa, porque de alguna manera son testimonio de nuestro compromiso con la excelencia investigadora y con la innovación. También porque congresos como el que ahora inauguramos nos permiten también compartir los últimos resultados de la investigación y confrontar e intercambiar ideas, lo cual resulta imprescindible si queremos avanzar en el conocimiento. También, y no menos importante, porque este tipo de eventos son el lugar de encuentro perfecto entre investigadores e investigadoras consolidadas y aquellos investigadores que acaban de empezar su carrera investigadora, lo que sin duda les motiva y va además consolidando vocaciones. En este caso, además, somos anfitriones de un congreso que, con más de 600 participantes, 660, apuntaba la profesora Roig hace un segundo, y alrededor de 40 ponencias, aborda un tema de absoluta actualidad y nos brinda una oportunidad única para reflexionar y debatir sobre el modo en que la inteligencia artificial puede y debe contribuir de forma responsable a la mejora del aprendizaje y de una oferta formativa enriquecida con nuevas posibilidades tecnológicas. Este es el objetivo que se plantea desde ICEAI 2024, un objetivo que se aborda, como no puede ser de otra manera, desde una perspectiva multidisciplinar. De hecho, como ya se ha comentado anteriormente, el Congreso es el resultado del esfuerzo conjunto de dos grupos de investigación de la Universidad de Alicante, el grupo ROBIT, especializado en desarrollo de tecnologías inteligentes, y GIDU Edutic, dedicado a la innovación educativa. Combinar la experiencia técnica de inteligencia artificial con el conocimiento pedagógico es sin duda una fórmula indispensable para diseñar soluciones técnicamente avanzadas y profundamente significativas para la comunidad educativa. Así lo demuestran los resultados del proyecto MEVAI, en el que participan ambos grupos de investigación y en cuyo seno se organiza este congreso. El enfoque multidisciplinar del proyecto MEVAI no solo amplía nuestro horizonte, sino que también enriquece nuestras prácticas. La educación, tradicionalmente arraigada en metodologías humanas, se beneficia inmensamente al integrarse de los avances de la tecnología artificial, de la inteligencia artificial. Del mismo modo, la tecnología también encuentra su propósito más noble cuando se pone al servicio del desarrollo humano. Este cruce de caminos, que ICEAI ejemplifica perfectamente, nos impulsa hacia un futuro en el que la educación no solo se transforma, sino que se humaniza también a través de la tecnología. Quiero por ello felicitar a todo el equipo de investigación y animaros, Miguel, Rosabel, a que continuéis avanzando en esta dirección, para la que sabéis que contáis con todo el apoyo de la institución a través del Vicerrectorado de Investigación. Antes de concluir, quiero expresar mi más profundo agradecimiento a todas aquellas personas que han hecho posible este congreso, al comité organizador, que ha trabajado de forma incansable para que este evento sea un éxito, también a los ponentes que han recopilado sus mejores resultados de investigación para compartirlos estos días con nosotros, con el único fin de contribuir al avance del conocimiento y, en definitiva, a la mejora de la calidad de vida de la sociedad. Estoy seguro de que las discusiones que se produzcan a lo largo de estos días contribuirán a establecer los principios y directrices que guíen el desarrollo de las tecnologías educativas en los próximos años. Por último, quiero dirigirme a todos y todas las asistentes, tanto presenciales como los que nos siguen online, y les invito a que participen activamente en cada una de las sesiones y les deseo también que tengan unas magníficas y fructíferas jornadas. Estoy convencido de que este primer Congreso de Inteligencia Artificial Educativa será solo el inicio de una larga conversación que trascenderá a estas sesiones. Con estas palabras declaro inaugurado el First International Congress on Educational Artificial Intelligence. Muchísimas gracias a todos por su atención.
Hasta luego, Juan. The first invited speaker is Sebastián Layé from the Sorbonne University. Dr. Layé is an associate professor of computer science at Sorbonne University in Paris, France. Before that, he was a postdoctoral research fellow and a research associate at the University of British Columbia, Canada, and an AI researcher at UME Academy. He received his PhD degree in computer science from the University of Grenoble in 2013. His research is in human-centered AI at a crosswalk of AI, human-computer interaction, and cognitive science, with application to education, public engagement, and information visualizations. He has won a Best Paper Award at IDA 16 in Intelligent Virtual Agents and was runner-up for Best Student Paper at AA in Education 13. Thank you very much for being here.
Thank you for the introduction.
Buenos días.
All right, I hope you hear me remotely. So 3 different examples, and I will show a bit more later. There are plenty of evidence that those open-ended learning environments are very effective at fostering motivation and learning in different learning domains. It's been found as early as in the 90s, so it's not a recent idea. But what also has been documented over the years is to some students it can be disorienting or even confusing because everything is available in the interface, and it can be quite challenging for some students to understand, okay, what do I have to do exactly? Some students get stuck right away, and other students, they do things, but they don't really know if they're going to the right direction. They're having a hard time assessing whether what they're doing makes sense and quantifying their progress and learning. And it's also sometimes it can be hard for, imagine high school teachers trying to use these kind of tools in their classroom. They have multiple students, some get stuck, and it's hard for teachers to understand how they can help the students in this kind of environment if they are not themselves experts in this kind of open-ended principles. So one of the possible ideas, and that's where artificial intelligence comes in the pictures, is to alleviate some of those difficulties is to design what we call adaptive support or personalized support. We can use the 2 terms in here, with the idea that we will have some little intelligent component that will monitor what the students are doing and try to provide them with some help during the interaction. So that's part of my research. Of course, because the interaction in those environments is completely unrestricted and very exploratory, the problem from a computer science or AI point of view is we have a very, very large space of possible action, states, and basically interaction paths that the student can take on. There's no 2 students that do exactly the same sequence of action. It's not possible. And so navigate through this very large space is not easy. In particular, it's very hard if you just look at the student data, what action they've been doing, whether they are moving to the right direction, is it optimal or correct what they're doing or not, are they exploring in a meaningful way. Very hard to know that just from the data, and even harder to link that to higher level constructs such as are they learning, are they motivated, and these kind of things. Another difficulty is that in some domains, especially when you have a creativity or designing components, it might not be even possible computationally to know whether the students, what they've been doing at the end, it's correct or it's answering the problem. Sometimes we don't really know. We don't have a way to measure that. So my approach in my research to try and still tackle these difficulties and still try to design intelligent personalized support in those OERDs is to combine students' data and human expertise. So students' data, we have the data, we will try to mine this data to surface some salient or relevant behaviors that we can use. And human expertise here, I mean teachers and educational psychologists who can provide more insight into those models and help them design the support. So if I try to formalize it with what I call the adaptation loop, the idea is students interact with an OERD, regardless, some example of the one I've been using. The first step is that we want to build some kind of student model that will inform us about some relevant trait or characteristic of the students. Historically, what we want to model, what we want to track is student knowledge, are they learning? But you will see that in those OERDs, it's going to be a little bit more behavioral in nature. And once the student model has ascertained from the student data that, hey, this student needs help, then the next idea is, okay, we want to design support that can be delivered in real time inside of the OERD to help the students, guide them toward the right direction or help them assessing their progress. And of course, the students keep interacting with the learning environment, so we keep looking for opportunity to collect data, update the student model, and look for possible need for help. So that's the general framework. And of course, there are different questions related to each of these boxes, but for the student model, the question is, what do we want to model, and more importantly, how can we do that? The how is often done with, at least in my research, with artificial intelligence and data mining components. Then we have the problem of, even if we have a very good student model, how can we actually help the students inside of the OERD? What kind of feedback can we provide them or support that will help them? And here, we are more at the crossroad of AI and ICEAI, right? It's a decision problem, what help to provide, but it's also an interaction problem, human interaction problem. What is the best way to provide that in the learning environment? And the last thing I will add, because that's what I said initially, is what is the role of the human? I mean here the expert, the teacher or the educational psychologist. So all those questions I will look into them through two use cases about two different learning environments to teach computer science in elementary and high schools. So it happens that those two projects are complementary, so they are nice to talk to them together, but I'm not limiting my research to computer science teaching. It happened that they are very complementary. So I will start with the first one, Unity City. So this one, it's a collaboration with two researchers from the University of British Columbia, Rohit Murali and Christina Konati. And here the idea is we want to start from student data and bring in human expertise data. So first I will talk a little bit about what is this learning environment, Unity City. So it's actually an environment designed by a company called Umi Academy. And the idea is that they want to teach computational thinking, which is the ability to basically design algorithm to answer a problem computationally. So teach computational thinking to elementary school students using the Unity game engine. So they have a modified version of Unity. I don't know if you know Unity, but it's an engine to create games. And because of that, it's basically a sandbox, right? You have your interface and you can design whatever games you want with whatever game object you're provided. No limitation. It's the same Unity game engine as used by professionals to create video games. With that, within this environment, Umi Academy added some mechanisms, some game objects that the student can use that are related to specific CT skills, like using loops, conditions, design a solution to a problem. And they have a curriculum that spans across 5 to 8 lessons. And at the end of the day, students are supposed to create little platformer games like this one, for instance. So that's what they do. How to design personalized support in this environment. So if I go back to my adaptation loop, the first thing I will show is the first part, the student model, and I will show that the model we design here are semi-supervised. They are based on the behavior of the student, and we used to do that a framework called FUMA that I will describe later. And then I will talk about how we design a pedagogical agent to deliver feedback to the students in this environment. And so where the human is involved in this work, but in two steps. First, we ask teachers to help us assess whether the model makes sense. And then we co-design the feedback integrated into the learning environment with them. So in this project, I said we start from data, right? And we will bring human expertise later. So to start from data means we need data. Makes sense. So the first thing we did is we conducted a field user study, meaning we went to summer camps all around the Vancouver area in Canada. We had 130 students involved. And the idea is we just wanted to sit in the meantime? Does it pop? Okay. So I will sit in the meantime. It's not really comfortable for me, but okay. So we had 130. Yeah, it's not gonna work. Just temporarily. Yeah. Oh, can I actually move it? Yeah, I will do that. It's better. Okay. So 130 students. The idea we just wanted to collect data about how they learn with Unity City, the basic version, right? So the idea how it works is usually in the summer camps, the students will play a little game and discuss among themselves, like some game mechanics that they have been playing, so the game are picked with this idea in mind. Then the teacher will introduce some CT skills, so every new lesson they introduce something new, and they will also give instruction for a challenge that will come next. And the challenge is when the student can explore freely. No problem. You want to? Sounds good, yeah. So the blue part here is where students can freely and explore the Unity City environment and create little video games with specific goals and constraints that they are provided with. And at the end of the day, they can play each other games to have fun, right? So what we're interested in too is the blue part, where they actually interact with Unity City on their own. What we did is we just added a logging mechanism so we can collect all of the possible actions that the students are performing in their environment, and that's it. We were actually not in person in the environment, just the teacher and the students in the summer camps, and that's it. And this part in blue lasts about half an hour, and for simplicity here, I will just focus on the very first lesson of the summer camp. All right, so now I will talk about the FUMA model that I mentioned before to design a student model. So that is that we start from the data we logged from the 130 students, and we first, I think I will get my microphone back. All right, easier this way. So we start with the log data, the raw data, all of the action that the student performed in the Unity City, and we turn them into vectors of interaction features, which are basically descriptive statistics about how they used all of the possible action and game objects. Then the first part of Unity City, of the FUMA framework, is use some clustering algorithm to group together students who behave similarly in the environment based on their vectors of features. And it's meant to start grouping those students a little bit together, reduce the complexity. And then within each of the cluster, we then mine association rules using a specific algorithm that will basically extract what are the most salient behaviors within each cluster that explain the best the behavior of all of the students. Basically, what are the behaviors that most of the students within each cluster tend to exhibit repetitively during the learning session. Here is an example of a rules. So the first part, frequency of rescaling the balls, is basically one feature. And in this rule, we know that for those students in this group, it was low. So they had a low frequency of doing this particular action, for instance. And then a lot of the rules looks like that. So it's very behavioral in nature. But the nice part is we can actually, because clustering and rules are pretty interpretable, we can look into them with the teachers and look and see how they relate to learning. So if we when we applied this framework to our data from the 130 students from Vancouver, what we found first is that the optimal number of clusters was 2. It's often the case that we have not so many clusters, but that's how it is. And when we looked into those 2 clusters, we tried to, so the teachers are grading the challenge at the end, they give a grade to the students. And when we look at that, we found that in one cluster, the blue one on the right, all of the students completed the challenge successfully. So we call that the high-performing or HP cluster. Doesn't mean that they learn better, but at least they perform well on the test, on the challenge. For the other cluster in green, half of the students failed. They did not even complete the challenge, so we'll call it the low-performing or LP clusters. We had a bunch of other metrics that were all telling us basically that the guys in blue were the more effective students, and the one in green were maybe struggling more. Once we got that, we look into the rules that we mined from each of those 2 clusters, and the first thing we do to make sure that those rules are actually meaningful, like it's a sanity check, which check whether they are predictive of whether the student belongs to their own cluster. The idea is that if we do that in cross-validation, then we can see if the rules that FUMA mined, the framework mined, can generalize to new unseen students, because that's what we will want to do at the end of the day. So just one little results here. The idea is that we use the rules to see whether they can predict the cluster a student belongs to over incremental window time. So at the bottom, you have the percentage of interaction from basically 0 to half an hour, so 100%. And when we look at the accuracy of the rules at predicting the student cluster for new unseen students that were not used for training the framework, we see that after about 20% window, the green line, the dotted line, which is about 6 minutes, the accuracy of the FUMA framework was about above 80%, 85% already. So that's just a sanity check telling us that, okay, those rules, they do capture salient behavior that tend to generalize to new unseen students. We also look at the internal validity of those rules, from the teacher's point of view, and we did that by basically showing the rules to experienced teachers and ask them first, do you understand what this rule means? And do you think this rule belongs to a student who is high or low performing? Of course, we don't disclose to them the FUMA output. We just want to see whether the teachers will come to the conclusion. And in almost all of the rules, except for one, teachers were like, I know what this means. Actually, I think I've seen that in my class, and I believe it's HP or LP, so high or low performing. So which is another confirmation that, okay, those rules, those behaviors that the rules learn, they seem to be to some extent relating to what the teachers can see in the classroom. We also asked the teacher actually, would they give help to the students if they were to see these rules and for the LP rules, and they all said yes. So I'm just going to pass a bit on that, it's too much text. All right, so now that we have our FUMA student model, we learn salient behaviors for 2 clusters, HP and OP students. Now the question is, can we use that in real time? You know, basically, if FUMA predicts that the student belongs to is a low-performing student, can we look at those rules that they triggered and try to see how we can help them? So that's the next phase, which is designing the pedagogical support that we can integrate into Unity City. So when we use FUMA in real time, the beginning is basically the same. We still collect the same action from the same Unity City environment. We still build the exact same feature vectors, so nothing different here. Except that now it's in real time, so we already know the rules and the cluster that we're looking for, so we're just basically trying to use those rules. We have like a custom online classifier that will use the rules to see whether the student right now belongs to HP or low P, or sometimes if there's no data, no prediction, but that's it. And the next phase is, okay, for students who belongs to the low-performing cluster, how do we help them? Basically, we look at what is the latest rules that they had triggered, and we will attach plug in some kind of like adaptive support that we design with the teachers. So so this part is a bit more ICEAI, but basically we use a user-centered design approach, if you're familiar with ICEAI. Right, the idea is that we co-design the feedback with the teachers. Right, we show them the rules, the FUMA rules, and we say, how would you help these students? So we work with the teachers to do that. Then we test with students, and we see how the student perceives the rules, do they learn better, etc. And then we iterate. We actually iterated a couple of times until we got a design that was having an impact on student performance. You can see the publication on top. It took us about 2 years to get there, so not a quick process. And we also, at the same time, tested the usability of a little pedagogical agent that we included in Unity City. So just to give one example of the final design we came up at the end of the day. So let's take an example. So FUMA predicts this particular student is low performing. Here is the latest rule they triggered. Rule number 1, they had sparse interaction with special object that they need to use to complete the challenge. So the pedagogical agent will intervene and give the following support. So first, it will show the first speech bubble, which is the hint, and basically it's just a gentle way to nudge the student toward maybe try to do something different, right? At this point, the student can decide to close the hints or click on the Tell Me More button, and if they click Tell Me More, then they will have the number 2, the second speech bubble, a more directed prompt inviting the student to actually do something very specific. And the image is actually an animation showing how to do that in Unity City. So the students see, right, the little animation, and they can reproduce the steps themselves in Unity City. For instance, here they want to try what the green platform does, right? So this is a kind of sequence speech bubble we integrated into Unity City, and there is one sequence of hint and prompt for each of the association rules in the low-performing cluster. You have actually a little video showcasing how this works, so you can scan the QR code and check later. So now, okay, we have designed our little agent and everything. Does it work? That's the next step. And to know if it works, well, there is only one solution, is to run a new user study in Classroom. So for this study, we got 366 students, same demographics, about grade 4 to 6 in North America. The only difference is now this is after COVID, so the company moved to fully remote classroom, no summer camps, no in presence. But the curriculum remained the same. It's just now we had students virtually connected to a virtual classroom with a teacher the same way, so it's just modified bits of things. We also had some students who were on their own, because now students can literally join a class on their own and do the material, so it's something different. That's why I said it's like in the wild, in bracket, because here we don't really control who are the students, but that's what we wanted. We wanted like a real use case of student learning with Unity City. So in terms of the session now, what the company did is that they integrated a little video that basically demonstrates the city skills and introduces a challenge. The challenge part is exactly the same. Students freely interact with Unity City remotely to design a game that matches exactly the same constraint and goals as before, so nothing changed. And they still play each other's game at the end. What we change here is that, of course, we assign students to two conditions. The control condition, we don't have the pedagogical agents integrated, so students interact as usual. And the adaptive one, where the agent was enabled. And of course, we did that per classroom. So within a single classroom, students have either access or no access to the agent to avoid discrepancy like that. Some results. So first of all, what we found within the adaptive groups, the students who had the agent enabled, is they got the agent intervention twice on average, but there was some variation. Some students got no agent intervention at all, and some got as high as 6 agent intervention within the half an hour to do the challenge. And when we look at the performance of the students, so again, we were looking at the grades assigned by the teacher at the end. So we saw a significant improvement, meaning the student in the adaptive group with the agent, their grades were significantly higher than in the control group. The teacher didn't know which student belonged to which group, so in terms of grading, that was pretty fair. And so this is showing to us that, okay, those agents, they seem to have had an impact, at least on the likelihood of the students getting a better grade. All right, so some conclusion for this first use case. So first of all, this was nice to confirm that, if we both mine the student data and have the teacher help us co-design the feedback, we managed to get some positive effect on the student learning. Something that I want to talk a little bit about is, importantly, the student model, I call them shallow, because they're very based, they're learning like salient behaviors of the student and whether they relate to performing well or not well, but by no means are they revealing anything about specific skills or knowledge or motivation of the student, right? It's purely behavioral based, but thanks to that, that means we can handle the complexity of those open-ended learning environments, extract those behaviors, interpret them with teachers, and design help with them. So that's, the price you pay for having this shallow student model is that at least you can design something that seems to be helpful for the students. And just want to add, because I mentioned for the ICEAI part, the design of the agent and the speech bubble, it took us about 2 years to get there with several iterations. And what we found is sometimes, you have the same student model, but you modify a little bit how you show things in the interface, and you already have significant impact on student performance. So it's something not to be neglected, and it's very well known in ICEAI. You have to iterate over design and stuff like that. But here we realized that firsthand, and it's very important to remember that if your ICEAI doesn't make sense, no matter how good is your AI, you won't have a good result on student learning. All right, so that was the first use case. I'm going to move on to the second use case, second and last. So this one is Pirates, in collaboration with Mathieu Brantong from the University of Western Brittany. So here the idea is that a little bit reverse. We will start with observing human expertise and try to map it to the students' data later. So kind of the opposite idea. So first, what is Pirates? So Pirates is a serious game to help young learners high school students transition from Scratch programming to Python programming. So if you're not familiar with Scratch, it's kind of like a language for programming in a visual way by assembling blocks of programmatic instruction. It's meant for a very young learner, basically, and they can program little things without having to worry about the syntax of the language, right? So here the idea with Pirates is that students already know Scratch, so they know how to design little algorithm with loops and condition and etc. And we want to help to speed up a little bit the transition from Scratch to Python to actually programming with an actual text-based programming language, because they already know those programming constructs, so we can try to fasten this transition. The idea of the game is very common in all of those programming games. Is you write Python code at the bottom, and the Python code is going to control for the behavior of the little character. You see the little parrot guy, with the idea that basically the parrots must navigate in the maze, collect object, and open the chest at the end. So the game idea is very common, and importantly, there were 8 levels in Pirates, and each level was introducing one new programmatic concept, right? So 8 new programming concepts at the end of the day. Something that we added compared to most games is here in blue, so students can access any of those like programming documentation that will show to them how a specific block in Scratch. So if you don't know Scratch, that's what it looks like, how a block in Scratch corresponds to Python programming. And this is a documentation. It's also kind of like the course material because, of course, there is some little instruction about what each of those instructions does and how they can be used and in Python. So here, what we did, so because each level was introducing a specific programming concept, my colleagues who are more educational psychologists from a faculty of education, they wanted to know how teachers, experienced teachers, do help the students in each of the game level. So I'm not going to talk too much into this because this was their work, right, in education, but they did a lot of field study in classroom to observe how teachers were like, what type of help the teacher would give to their students while they were learning with pirates. And what they found, I'm going to skip, so I say, what they found is that most of the teacher's intervention can be nicely mapped to a framework of feedback, the one proposed by Cesar Narcís in 2013. So basically, they were categorizing all of the teacher's intervention into one or the other type of feedback that Narcís proposed in their framework. And because they realized, okay, it's kind of matching well, they also went ahead and with the teacher's design for each of those types of feedback, a feedback that can be integrated in the game. So here is what it looks like. So at the bottom in bold, you have the types of feedback from the Cesar Narcís framework. And the images show how this was actually translated into the game with the help of the teachers. So if we go from left to right, the first one is eliciting task rule for those students who are stuck and don't know what to do, right? The feedback is to try to help them understand breaking down, how to solve the level into sub-steps. And when it's implemented in the game, you have a little parrot character, a little agent that will move around and explain to them basically what are the different sub-goals to complete the level. So eliciting that. The second feedback is eliciting the concept required to solve the challenge. As mentioned, one level means one new concept. And so if the student, for instance, had no idea, I need to use a for loop to complete this challenge, then after some time, the teacher will give his feedback. And so this is implemented by referring to the memo, telling the student, hey, to solve this level, maybe you want to look at the programming documentation about loops. If students are still stuck, then the agent, the feedback teacher will give little snippets, so we'll explain a little bit how exactly do you convert this concept into Python programming. So the parrot shows a little snippet of code. And the last feedback that is meant for really those students who are stuck and about to give up is to show them the correct response, the correct answer for this level so they can move on to and try on the next level. This is meant only for students who are like, I'm giving up, I don't know what to do, right? So sometimes teachers do show the right solution. So what we wanted to know next, and that's where I come into play, computer science come into play, is, okay, when do the teachers decide to give each of those 4 types of feedback, and can we map that to the student data, what the student has been doing so far? So what we did to collect this kind of data, to train this kind of agent, is we designed a user study in classroom, where we added this red panel at the bottom where teachers can actually select one of the 4 types of feedback, and this will trigger the little parrot character to appear and provide the feedback as it was implemented with the teachers, right? So that's all the teacher will do. Of course, if the teacher were not satisfied with any of the 4 feedback, like, oh, I think this student needs different help, they can click the other red button and then they can give a verbal feedback to the students. But this way we can know when the teacher decides to give each of the 4 feedback types or give a different feedback more customized to the students. So if you're familiar with Wizard of Oz experiment, it's about the same, except here there's no deception because the students knew it's the teacher who was triggering the feedback. But in the idea is the same. The teacher plays a role of the feedback decision model. So to do this experiment, we had 215 participants, students participating in 2 different high schools in Brittany, with 8 different teachers. Those teachers were all experienced and all used pirates already in their classroom, so they know the game, and they know how to teach this material. And of course, some of them participate in designing the feedback, and others, we explain to them exactly what those 4 feedback types are. All of the students had taken the course about Scratch, so they know how to program in Scratch. They had no experience with Python. We excluded 2 or 3 students who already had done a bit of Python stuff because that's not our target population here. So a class with parrots is as follows. First, the teacher gives a short introduction about the game, what they have to do. Then students are basically free to explore the learning material and solve as many levels as they can. Remember, there are 8 levels on their own. And there's kind of a debrief at the end. So here at this point, what we did is, again, us researchers were not in the classroom, but we just added the mechanism to log all of the student action in Pirates, and including, of course, which feedback the teacher decided to trigger in the red panel. Of course, we collect the student data and the teacher's decision to trigger one or the other feedback. And this was spaced into 3 lessons, so 3 hours in total of interaction with Pirates on 3 different days. All right, so looking at the data we got from this first study, what we found is that in 85% of the time, the teacher was satisfied with one of the 4 feedback types that were predefined. They triggered those, and so meaning the remaining 15% is they gave another type of feedback, like a verbal feedback, different than the one we had, but we're already pretty satisfied to see that, okay, in most of the cases, those 4 feedback types implemented as they are were sufficient for the teacher to address most of the student difficulties. We also look at the possible sequence, the sequence of feedback that the teacher were giving to each student, because student can receive multiple feedback from the teacher. And here what we saw, but it's obvious, is that the teacher, they don't give the feedback from the most general to the most in incremental order, from eliciting the task rule to giving the correct solution. They personalize the order of the feedback they give to each student, which is what we saw by plotting little like a graph of the sequence of feedback given by the teacher. So that's just, it's obvious, it's just a nice sanity check to know that, okay, that's what the teacher do. So what we wanted to do next is, okay, so we have our student data, we have the label provided by the teachers. Let's build an AI policy that will decide for the teachers what feedback a student needs at a given time. And so the framework looks a little bit similar than before. At first, we start with all of the log action we had in Pirates, and we convert them into feature vectors. Similarly, it's like descriptive statistics about what all of the action the student has done in Pirates so far, and also we pass all of the code they have executed in the game. And so the idea is that every single time in the classroom, one of our 8 teachers decided to give one of the 4 feedback types, we look at the data, student data before that, and we try to see if we can build supervised machine learning classifier that will predict the feedback type. So here you see, unlike Unity City before, where everything was fully unsupervised because everything was fully unrestricted, here we have the labels. The teacher told us, at this time you need to give concept feedback. So we had 4 labels, 4 types of feedback. This is just a multi-class classification task. So that's what we did. And we added some meta rules to control for some side effects. I will talk later about that. So when we look at the results of the supervised machine learning classifiers we tested, so we tested a bunch with some hyperparameter tuning and etc. Like you know the drill. What we found is the best model was a random forest, which in our experience is often the case. I mean, it's a model that's worked nicely with like this kind of like small-ish data set, right? We had about 200 students and about 2,000 to 3,000 feedback provided by the teacher, so 2,000 to 3,000 sample with labels. So in our experience, random forests work very well on this kind of data set, and we compare them against the other classifier we tested and different baseline, and it was significantly the best in all of the levels we studied. You see on the chart, so the random forest, the F1 score, so the precision of the random forest is on the top. At the bottom in gray, you have like a random baseline, just predicting the feedback type as random. And in green in the middle, we have kind of like what I call a teacher baseline, which is providing the feedback in the most likely order for that level based on what the teacher has been doing in the classroom. So based on those little graphs that I showed you before. This is just to have like a baseline that is a bit more meaningful than just giving a random feedback. But still, the random forest was much accurate, much more, significantly more accurate, which is nice because it's using the student data. When we inspect, the nice part with random forest that we can look at the features that were deemed the most important by the random forest on the training data to make this prediction. And when we look at that, what was nice is that in each of the level that we used, the most important features are always related to how much time the student spent in the programming, documentation, the memo, related to the concepts required to complete this particular challenge. So for instance, Level 1, it's a simple for loop, so you don't have to understand the little labels, but a simple for loop. Level 3 is variables. And so it's showing to us that, okay, that's random forest. They seem to have been learning stuff about the programming documentation that makes sense for that level. And that's probably what the AI is using, is like, depending how much the student use the programming documentation for that level, it's revealing whether they need feedback or not, and what feedback they need. Of course, other features, but I'm not going to go into details. I'm going to also skip this. All right, so once we got that, we still, before actually integrated the random forest inside of Pirates, we added 2 meta rules to control for 2 side effects. Again, we fine-tuned this with pilot testing on new students, a few students to pilot test those. The first one is, in some cases, 4% of the times, the AI will predict that the student need to be provided the correct solution, whereas it was not the label, so it was not what feedback the teacher wanted to give. Of course, it's only 4% of the time, but still it's pretty bothersome, because in an open-ended learning environment, giving the correct solution is what you don't want to do unless you really have to, like the student is about to give up. So what we did to prevent that after pilot testing is we basically prevented the AI, the pedagogical agent, the parrots, from giving this feedback type if it's too early in the game level. And also, after discussing with the teacher and seeing how they should be involved in running the class, we decided that if the confidence of the random forest in its prediction was below 60%, again fine-tuned by pilot testing, we will actually not give a feedback, but the parrot will tell the student to, hey, ask your teacher because I'm not sure. And the idea was like, rather than giving a feedback that we know where we don't have high confidence into it, better to keep the teachers involved. And the threshold was decided so that basically the teachers will be solicited not too many times, but just enough when they need it. Something I did not mention before, but in the first observation, what they found too is that it's physically impossible for one high school teacher with like 20 to 25 kids to help all of them. Like, if you look how much time it takes them to help one student, multiply by 20 students, there's no time. So the idea here was to optimize the time of the students, so that the teachers, so that they can actually help everybody. All right, and last thing, and I will conclude on that. All right, we have our little parrots, the AI decision model to decide what feedback to give, and our meta rules. Does it work? So unfortunately, this is ongoing, so I'm going to show some preliminary results. But so far, we have 66 participants using parrots with the mechanism. We're aiming for 200 at the end of the experiment, at the end of the month. The interaction with parrots is exactly the same, except we now added a standardized pre- and post-test to measure better learning. The pre-test is in Scratch, and the post-test is in Python, and they're both based on some, like a standardized test, so they're similar, and the idea is to see whatever knowledge that in Scratch at the beginning, was able to translate it, and maybe more in Python at the end. Again, students were randomly assigned to 2 conditions, with and without the agent, the parrot agent, enabled in their class. And so again, the results are very preliminary because we're still running the study, but so far what we saw is that students asked for feedback, or got feedback 19 times on average over the 3 hours interaction and the 8 game levels. And when we look at learning gains, so the improvement from pre-test to post-test, so far we seem to be having a very positive effect, meaning students in the adaptive group with the agent seems to have higher learning gain than students in the control group with no agent. Of course, still ongoing, so after we got all of our students, maybe this won't be the case anymore, but for now, this is significant. So some conclusion is, again here, we were able to design, we hope, meaningful feedback by, again, combining rich teacher expertise, which was a bit tedious to collect, and student data. But we were able to use a more supervised machine learning approach because, again, each game level was targeting one particular programming concept. So it's still open-ended in many ways. Students can do whatever they want in Parrot, but at least thanks to this little trick, it was a bit easier to design the AI component. And again, the models are very simple. They're based on the student behavior, so still not relating to anything. It's still shallow in itself, but it's still interesting to see that we can interpret these models, show them to the teachers, and the teachers actually appreciate, and it's nice to get the trust of the teacher to be able to show them what the models is actually doing and what it looks like. I just wanted to conclude on, to show, take a step back and talk a bit more about my general research. So what I talked today about is what I showed in red, designing student model and personalized feedback for open-ended learning environments. But in my research, I have been looking at other type of environment, in particular MOOCs, hypermedia, simulation. I have been interested in looking not just at the student log data, the action, but also at more multimodal data, in particular eye tracking, but also right now we work with haptics like robotic legs to teach surgery for medical students. So other type of data, not just action. And I also use AI not just for designing personalized support, but also to understand learning and self-regulation, which basically falls into the learning analytics community. So just wanted, if you want to talk about what I presented or any of the other boxes, feel free to come forward. All right, muchas gracias, everybody.
Thank you very much, Sebastian. I think that was a great work you're doing, and we know how important it is for education to do a formative assessment. I have a question, and is how can you ensure that the feedback that we give to a student is always relevant to the context and when the learners are so diverse?
Yeah, well, so first of all, what we do, and it's not that easy, is we go in the classroom, we conduct user study on the field where we researchers are not physically there, only the teacher and the students. So we try to evaluate the feedback in the most naturalistic settings as possible. And then, we have no way to ensure that the feedback will always be relevant. It's based on AI, and AI is, sometimes makes mistakes. But what we try to do is we try to at least, iteratively pilot test and test as we go with the teachers until we got something that looks satisfactory. And then, well, there's a little ethic part we didn't mention. It's sure when the AI gives the wrong feedback, the only person who can intervene to remediate to the situation is the teacher in the classroom. That's why we try to have the teachers collaborating with us as early as possible in the project, and we decipher for them what the AI is doing, so they kind of understand that, okay, sometimes the AI is wrong and I will have to step in. When we talk with the teacher, that usually that what they tell us is like, oh, it's great, it's doing a lot of good things, but sometimes I notice, often they're like, oh, sometimes for that student I noticed the AI did this, but I would have done that. So, we try to minimize this issue. We cannot ensure that the feedback will be relevant 100% of the time.
Thank you. Do you have more questions?
Thank you very much, Sebastian, for your presentation. I'm not an ICT technician or anything. I'm a teacher and now a professor. So my question is more related into the educational field. And I was wondering, how do you think this kind of models could contribute to make education more inclusive regarding students with some disabilities or some functional diversities? Thank you.
Yeah, so it's a very good question because we have other projects where we look at another field of artificial intelligence called fairness in AI or DI, diversity and inclusion. So I haven't talked about that in this particular project, but we also run other studies where we try to see whether the AI we're building are biased against particular subpopulation of students, in particular students with disability, for instance. And I had a PhD student who's about to defend her thesis at the end of the month. She's been working on how to mitigate those issues. But she did find, yes, the model we use in education, they can be biased. Not always, but sometimes they're biased. When they're biased, if we have the data, we can really measure it, and we can do some stuff to mitigate it. So that's the AI answer from the AI point of view. Now, from the teacher point of view, whether it's easy or not to integrate this kind of technology in the classroom, given their diverse audience, it depends. It's difficult. Like what we saw, for instance, in computer science, one of the main things is the gender divide. We didn't see any impact of gender on any of our results so far in any of the things we've done, meaning that either there's no gender bias in the usage of those open-ended learning environment, or the feedback we're designing is not correlated with gender. However, with disability, that's a bigger problem, because can disabled students use open-ended learning environment in the first place? It's a big question. I'm not really in this field of research, but I have colleagues who are working more on rendering those environments user-friendly for different type of disability, but it's a entirely different research environment. You can find like many PhD students working on all those things. So it's an important factor, but people are looking into it.
Thank you. More question?
Thank you very much. It's so incredible and a wonderful work. And I want to know what is the point of view of the families, no? For example, when you involve children in this kind of studies, no? About the sensibility of the families about this kind of feedback or study. Thank you.
Yeah, thank you for the question. I would bet, first of all, it depends on what country and what age of the student. But for Unity City, this was in Canada, we had to collect parents' informed consent for the children to participate in our study. So I think the company was mostly in charge of that, but they got consent from almost all of the parents. Basically the thing is, as long as we explain clearly, what we're doing and how it's not going to harm their kids, or the risk is minimal. So in Canada, parents were very willing to do that. Of course, some parents, said no, I don't want my kids the data of my kids to be collected. We did not follow up to ask them why exactly, so I wouldn't be able to answer, but that was it. For the French one, it's a bit different because we were in high school, and the high school itself is responsible for informing the parents. It's a bit different in France. You don't have the parents to give informed consent, you just have to inform them whether they consent or not. So again, we were not really in contact directly by the families, but I know that the high school contacted the parents and they were informed that we're doing this kind of experiment. Now your question is touching a little bit more on the sociological aspect of the work, which I am really not an expert, so I don't want to answer a thing that I don't know about. But for us, that's how it works, collecting informed consent or informing the parents. As far as I know, most parents were okay with it.
Thank you.
Thanks so much, Sebastian, for a great talk. So you talked about the shallow student models, and I think that's kind of a byproduct that you're, I guess, for these projects, only using log file data. So kind of two-part question. The first one is, if you were now going from log file data to multimodal, right, how do you foresee using multimodal? Will it enhance the student model, and how? And I guess related to that is then how would also that change the quality of the types of feedback that students would get?
Yeah, so going into multimodal, so it's something we've done a little bit, but it really depends on the modality you're looking at. So when we look, one thing I've done with eye tracking is, if you go back to the literature on eye tracking from a psychological point of view, and there's a lot of work that tells us this particular eye tracking features, like how long you fixate on something or how fast you look at the screen, most likely correspond to this particular behavior. So if you were to apply, for instance, the FUMA framework, and actually we did at some point with a different student, but you get those same kind of features, descriptive statistic features about the student gets behavior, you can interpret them. Our problem was not so much into building the model and interpreting the feature, is more that it becomes, the complexity of the rows becomes a bit too high, because then you have rows that are like, if students have this particular guest behavior, that means maybe something about motivation with this type of action, then they are low performing. So it's a little bit harder to understand, and also obviously harder to explain that to the teachers. In another modality we're working right now, I mentioned with the robotic legs to train medical students. And here the leg is full, we have plenty of sensors. Here, it's not like eye tracking. These sensors there's absolutely no way to interpret what they mean, like, whether the angle of the legs that the teacher is trying to manipulate, whatever. So we cannot interpret them. So here we move into a new land, which is like completely not interpretable multimodal student model. The way we see it is we cannot necessarily use that to design the feedback with the experts, like medical teachers, because we have no clue and they have no clue what it means. But our idea is like we can use it maybe to improve the precision, the accuracy of the model, like the model will be more accurate at predicting if you're high or low performing. And then to design the feedback, we will focus on those more interpretable behavior that we know. For instance, the student, I don't know, take an X-ray at this moment and not at this moment. So that's how we envision things. There's one more project where we use webcam to do facial recognition to infer the emotion of students and their motivation. But here again, we don't, I mean, there's some ethical problem with collecting the face and emotion. But again, we use it mostly to improve the accuracy of the model, not so much to interpret it. So multimodality is interesting. Some modalities like eye tracking are very interpretable in nature, but in other cases, it's not really that easy. I haven't talked at all about large language models, which is like a modality of speech, but it's just starting now. So we're starting to do some research about how students could use that. Using this model in open-ended environment is very difficult because it's very hard to prompt them correctly. However, we're looking more into how this can help us design the feedback. So with teachers, large language model, and us designing the feedback. So there's also some aspect about the speech modality or text modality that's interesting. But here it's really, we're starting literally like right now. So I don't really have result yet.
Congratulations, Sebastian, about your presentation and your work. I have read the concept of co-design. I think it's a very important concept in this topic. What do you think is important? I think so. But can you explain more about this concept in your research?
The concept of?
Co-design.
Co-design. Co-design, yes, sorry. I got it, yeah. Yeah, so that's where my ICEAI part come into play because, as I said before, my research, or as you introduced nicely, the research is at the crossroad of AI and ICEAI, and co-design is basically based on the user-centered design from the ICEAI. Like the very classic way to design interfaces is you don't design the interface yourself. You have the end users helping you, an expert helping you design the interface because technically I'm not a teacher, I'm not a student, so I could design the feedback the way I see is the best, but maybe that's not going to be useful at all for the students. So co-design means we want the end users, in that case the end users are two faces, teachers and students, to be involved to some extent to how we modify, to the way we modify the interface to provide this personalized support, right? So in theory, you could have also the students involved in designing the feedback with us, but what we did to keep it simple is we design with the teachers and we test on the students and we iterate, right? We see, so to see whether it works, so we collect qualitative data about how the students are performing in the environment, but also we collect usability data about whether they were satisfied, whether they found the feedback to be interesting, useful, etc. So, confusing, distracting, all those usability metrics. And so with that, we try to iterate to optimize both student learning and the satisfaction and the usability of the agent. But each iteration is, at least with Unity was teacher, then test on student. So, yeah. But again, if you have done any discussion with ICEAI, human-computer interaction researcher, they will tell you, the basic thing is if you don't involve your end users, whatever you will design may or may not work, but you won't have any idea before you actually run the study. And going in high school, doing a study with 300 participants in 2 or 3 different high schools, multiple classes, if you go there with a pedagogical agent that you design yourself and you're not sure whether it will work or not, it's kind of, it may work, but you may risk wasting your time.
More questions?
Hello. First of all, I would like to congratulate you for your excellent presentation. And I understand prior research that you performed concluded that personal traits or personalities of students influence the way they learn and the way they process feedback. I believe in this particular research you didn't took this into account, maybe, well, at some point you classified students into low performance and high performance. And the question is, do you think this aspect could be introduced into this research?
Yeah, so it's a good question. So we looked at, the one thing we look is gender, but we look after the fact to see whether it had an impact. We didn't include it in the design. So as you mentioned, I did some work before to try to understand how personality and motivational goals, for instance, and a few other things would impact how students use or benefit from this kind of pedagogical agent. Actually, a lot of this work was done with Roger in particular, so maybe this was a common work. But so there's two things. First, you collect personality motivations through like survey or questionnaire. It takes, then you can know. Or what we wanted to do is, can we build a different AI that will first predict what is the personality or the motivational goal of this particular student, and use that to inform our student model with something a bit more high level. But then you add a lot of complexity because, first of all, our AI to predict personality or motivation goals are not that good. Our accuracy were about better than the baseline, but we were limited to maybe 60, 65%. So in a lot of the time, we were not making correct prediction. And then when it comes to designing pedagogical intervention, feedback with the teachers, if you have to tell the teacher, okay, so you have this behavior, this corresponds to a low-performing student, and this student, I don't know, is extroverted and has a mastery-oriented goal in mind, it starts to be like the teacher, it's so complicated that the teacher, this profile is so specific, the teacher has no idea, and we have no idea exactly what to do. We will have to break it down into, okay, how we can provide feedback based on personality, how we can provide feedback based on motivational goal, then lump all of that together with the student model we design about behaviors. And so, yeah, if you, split this problem into different sub-problems, you study each of them, how to build AI for that, how to build modify the feedback, then you can get to something functional. But in these two projects where we started from scratch, added this on top of that would have been way too much. Now, in our research, we did find before, for example, with MetaTutor or other environment, that some personality traits, some motivational goals do impact how students learn or perceive pedagogical agents. So it is a factor that matters. It's just going the next step, which is how we need to modify the design of the feedback or the intervention. Based on them, I will envision a full research project to really nail it. And again, if you want to be principal, you will have to do iteration, co-design with people, with experts, or maybe experts in psychology who have a better idea of how different personality impacts how you want to use technology, for instance. But yeah, that would be my answer.
I think it's time to finish the presentation. So thank you very much, Sebastian, for your talk.
Thank you for
Bueno, buenos días. Vamos a comenzar con la sesión de comunicaciones. La primera comunicación se llama Perspectiva de los futuros docentes sobre el uso de la IA para proporcionar múltiples formas de acción y expresión para el alumnado con ICEAI, de Alba Gilabert, de aquí de la Universidad de Alicante.
Vale. Bueno, buenos días a todos. Soy Alba Gilabert Cerdá, soy profesora ayudante, doctora del Departamento de Psicología Evolutiva y Didáctica, aquí en la Universidad de Alicante. Bueno, en primer lugar, me gustaría agradecer a los organizadores esta magnífica idea de aunar dos conceptos clave, como es el uso de la inteligencia artificial en la educación. Y concretamente esta comunicación aborda uno de los aspectos claves, que es cómo utilizar esta herramienta de inteligencia artificial para crear recursos educativos para proporcionar múltiples formas de acción y expresión para el alumnado con necesidades específicas de apoyo educativo. Para ponernos un poco en el contexto, actualmente uno de los modelos predominantes en el sistema educativo español. Es el modelo del diseño universal para el aprendizaje, conocido por sus siglas DUA. Este modelo es una guía fundamental para crear materiales que sean accesibles y personalizados para todo tipo, para la diversidad de alumnado que tenemos en nuestras aulas. Bueno, poniéndonos en este contexto y bajo la tercera versión del DUA, enfatizamos este segundo principio, que se trata de proporcionar distintas formas de acción y expresión en el alumnado. Pues bien, dentro de este principio se engloba la idea de interactuar con el contenido que se ha creado, de expresar los conocimientos y desarrollar estrategias para el aprendizaje. Bueno, partiendo de este contexto de educación inclusiva y con las características que podéis ver en la diapositiva y que ya conocéis sobre la inteligencia artificial, parece ser que esta herramienta encaja perfectamente con el diseño universal de aprendizaje. Pues partiendo de esta idea, nos surgió el objetivo general de este estudio, de esta investigación, que es conocer cómo los futuros docentes perciben el uso de esta herramienta de la inteligencia artificial para la creación de recursos precisamente ligados con este segundo principio del DUA. Por lo tanto, nuestro objetivo general de este trabajo es analizar las percepciones de los estudiantes del grado de maestro en educación infantil como herramienta para crear nuevos recursos de aprendizaje, ligado, como ya he comentado, a ese segundo principio del diseño universal del aprendizaje, que se trata de incluir diversas formas de acción y expresión para el alumnado. En referencia a este objetivo general, pues hemos planteado 3 preguntas de investigación que van a guiar o que nos ayudaron a guiar más bien este estudio. En primer lugar, ¿cuáles son las percepciones que tienen estos futuros docentes sobre la efectividad de la IA para diseñar recursos educativos, para proporcionar esa interacción a la hora de trabajar con los materiales? Por otra parte, la segunda pregunta ligada a la expresión y la comunicación. Y en tercer lugar, las percepciones sobre el desarrollo de estrategias de aprendizaje, como puede ser la resolución de problemas, la planificación o la autorregulación. Pues bien, para contestar a estas preguntas de investigación se realizó un enfoque cuantitativo porque se querían medir, cuantificar esas percepciones sobre el alumnado del grado de maestro en educación infantil. Se utilizó un diseño no experimental descriptivo de tipo encuesta y la muestra de participantes fue un total de 90 estudiantes del grado de maestro de educación infantil de la Universidad de Alicante que cursan la asignatura de dificultades de aprendizaje y trastornos del desarrollo, respuestas específicas en contextos inclusivos. Para ello, para seleccionar esta muestra, se utilizó un método no probabilístico intencional, pues teníamos claro que el objetivo que queríamos era coger estudiantes que tuvieran formación inicial, tanto en inteligencia artificial como formación inicial en la respuesta inclusiva. La muestra total estaba formada por un 84,6% de mujeres y un 15,6% de hombres. La edad predominante de estos estudiantes fue de 19 años, puesto que la asignatura se marca dentro del segundo curso del grado de maestro en educación infantil. Bien, para recopilar todas estas percepciones se diseñó un cuestionario ad hoc denominado ICEAI, que estaba formado por 2 secciones. Una primera sección en la que se incluía información demográfica y conocimientos previos sobre el uso de esta inteligencia artificial y una segunda sección en la que estaba dividida en 3 dimensiones que abarcan 19 ítems en total con una escala Likert de 6 puntos. Respecto al procedimiento, pues se llevó a cabo en varias fases. En primer lugar, se realizó una investigación sobre la literatura científica que marcaba la inteligencia artificial para el uso en la educación y concretamente para el alumnado con necesidades específicas de apoyo educativo. Con esta revisión realizada se llevó a cabo la elaboración del cuestionario. Bien, antes de llevar a cabo finalmente esa administración del cuestionario, en las sesiones prácticas de la asignatura se han realizado varias prácticas que han utilizado herramientas que incorporan esa inteligencia artificial para la hora de elaborar recursos educativos. Por ejemplo, con Canva realizaron cuentos, las imágenes de cuentos educativos inclusivos. También realizaron historias sociales para el alumnado con trastorno del espectro autista y, por ejemplo, con Genially crearon también agendas visuales para el alumnado con TEA y, por ejemplo, con Suno, que es una aplicación para crear música, crearon canciones educativas para incorporar diversos contenidos y, además, los alumnos lo que hicieron fue a esas canciones que había diseñado la IA, le incorporaron un sistema bimodal para trabajar con el alumnado con discapacidad auditiva. Permítanme que me salga un poco del margen de la presentación de la comunicación para enseñarles un ejemplo de lo que fue una de esas prácticas que realizaron las alumnas. Voy a poner simplemente un fragmento. A ver si carga, si no creo que lo tengo.
En la granja hay un pato que dice guau, guau. En la granja hay un perro que dice guau, guau. Vamos a conocer todos los animales. Una vaca muy grande, una jirafa que alcanza el cielo. En el zoo hay un elefante.
Es muy pegadiza y seguro que os gustaría escucharla completa. La verdad es que tenemos que situarnos que estamos hablando de estudiantes de magisterio infantil y que están utilizando pues, herramientas. Lo que crearon en este vídeo, lo que creó la IA fue específicamente esa canción para trabajar el concepto de los animales y ya fueron las alumnas las que incorporaron pues, el extra que era el sistema bimodal. Bien, esto solamente es un ejemplo de las múltiples prácticas que hemos hecho a lo largo de la asignatura y para una vez que se realizaron estas prácticas, para que el alumnado tuviera ya un conocimiento más profundo sobre la inteligencia artificial y cómo crear esos recursos para atender al alumnado con ICEAI, se administró el cuestionario ya con esta perspectiva ya inicial sobre esta temática. Para el análisis de datos se llevó a cabo mediante un software estadístico con el SPS, realizando técnicas estadísticas descriptivas para el cálculo de frecuencias y porcentajes. Uy, me he pasado. No, está bien. Vale, a la hora de realizar los resultados que voy a exponer a continuación, se han abarcado en 3 figuras. Cada una de las figuras muestra una dimensión de esas áreas que se consideran centrales en esta investigación. En relación a la primera área, relacionada con la interacción al alumnado con ICEAI, se puede observar esa escala Likert que os he comentado antes, que se utilizó para el cuestionario, en la que va de 1 a 6, siendo 1 totalmente en desacuerdo y siendo el número 6 totalmente de acuerdo. Como se puede observar, en esta primera dimensión, la mayoría de los estudiantes, de los participantes, se concentran en las respuestas en el nivel 4 y 5 y destacando sobre todo el hecho del último ítem, que la IA permite diseñar recursos educativos accesibles desde una variedad de dispositivos electrónicos. En referencia a la segunda dimensión, la expresión y la comunicación para el alumnado con ICEAI. Pues bien, hay una tendencia, vuelven a repetirse esos puntos centralizados en el 4 y 5, 4 es algo de acuerdo y 5 bastante de acuerdo. Y destacan ítems como el hecho de que la IA cuenta con la capacidad de realizar recursos educativos atendiendo a una diversidad de formas de expresión y comunicación. Asimismo, permite la creación en múltiples formatos, texto, audio, y crear también redes sociales y herramientas web que sean interactivas para este tipo de alumnado. En último lugar, respecto a la tercera dimensión, que es el desarrollo de estrategias, destacan, vuelve a haber también otra vez una predominancia a esos puntos 4 y 5 en la escala Likert, predominando el hecho de que la IA facilita la creación de recursos educativos adaptando al ritmo y al aprendizaje de estos alumnos con EAE, también el hecho de que permite crear la autoevaluación, permite crear rúbricas, permite crear diversas actividades atendiendo a los roles que asignemos. Y, de manera general, me gustaría presentaros esta figura en la que se observa que los futuros docentes perciben esta herramienta de la inteligencia artificial como con un alto grado de percepción. Esto quiere decir que todos los ítems, la totalidad de los ítems, se puede observar cómo se sitúan entre el 58% y el 75%. Y si se tiene que destacar alguna de las dimensiones, se podría destacar ligeramente esa primera dimensión relacionada con la interacción. Bien, volviendo a eso. Vale. Como conclusión, pues una vez después de haber analizado los resultados, se pueden destacar 3 puntos claves relacionados con esas 3 preguntas de investigación. En primer lugar, el hecho de que la IA permita crear recursos educativos desde cualquier dispositivo, móviles, tablets, ordenadores, en un mundo que es altamente digitalizado, el hecho de que los maestros o futuros docentes tengan a su alcance elaborar herramientas educativas desde cualquier lugar, desde cualquier momento, pues es un punto que los futuros docentes pues, valoran considerablemente. Por otra parte, el hecho de que la IA se perciba como una herramienta útil para diversificar la respuesta en el aula, facilitando precisamente la creación de recursos educativos que van más allá del método tradicional, que es de escritura. Permiten la creación de audio, vídeo, música, como hemos podido ver, y, en último lugar, el hecho de que los futuros docentes valoren la capacidad de la IA para ajustar los contenidos al ritmo de aprendizaje, a las características individuales de cada estudiante. Punto que nos vuelve a conectar con el principio de la presentación en el que hablábamos de ese diseño universal para el aprendizaje, en el que cada alumno tiene un estilo de aprendizaje y nosotros, aquí me incluyo, los maestros, necesitamos y debemos adaptarnos a las características individuales de cada uno de los alumnos. En conclusión, de manera general, pues los futuros docentes cada vez están más concienciados del uso de la inteligencia artificial para creación de estos recursos que sean accesibles a todo el alumnado. Sin embargo, esta utilización de estos recursos necesita o va a depender de la formación que reciban desde el grado de magisterio. Y por último, permítanme que hagamos una reflexión, os deje esta reflexión conjunta, el hecho de que muchas veces tenemos la idea, ¿no?, de utilizar que la inteligencia artificial es como un error utilizarlo para que elaboren nuestras prácticas, ¿no?, en la universidad. Tenemos que darle una vuelta. La inteligencia artificial puede ser una herramienta muy útil para adaptar y Y son ellos mismos los que después de realizar estas prácticas te dicen, pero es que si yo no estoy detrás de esta inteligencia artificial, pues no puedo exactamente adaptar las características del alumno. Pues de eso se trata, ¿no? De dotarles, de darles formación para que las puedan utilizar, pero de la forma más adecuada posible. Y nada más, muchas gracias por su atención y cualquier duda o cualquier idea o intercambio de idea, pues es bienvenida. Gracias.
Gracias, Alba, por esta presentación. Tenemos tiempo para un par de preguntas. ¿Alguien del público?
Pues solamente quería preguntar, ¿cómo ves la implementación de este diseño del DUA con respecto a las tendencias de cooperación, integración, trabajo grupal, etcétera, que parece que no tienen la misma tendencia, ¿no? ¿Cómo podemos diseñar algo que sea DUA, pero que también lleve una tendencia? ¿Cómo lo veis? ¿Qué habéis pensado vosotros como grupo? Muchísimas gracias por la presentación, me ha encantado.
Bueno, muchas gracias por la pregunta. Pues la verdad es que el DUA muchas veces, bueno, hablando de los niveles de respuesta, y aquí me meto un poco más en temática de respuesta de inclusión, el DUA está pensado para que lo lleve a cabo un tutor o una tutora dentro de la clase, ¿no? Y entonces, a la hora de crear esos recursos educativos, muchas veces, y más cuando hablamos concretamente en educación infantil, el trabajo es comunitario de todos los profesores a la hora de elaborar una situación de aprendizaje. Entonces, precisamente se trata de formar a esos futuros docentes en específicamente qué es el diseño universal de aprendizaje y cómo puedo hacer yo con el resto de manera colaborativa, cómo puedo hacer para crear recursos educativos que encima sean adaptados a estas necesidades. El DUA sí que es verdad que muchas veces pues tiende a individualizar, pero también tiene un apartado, por eso es tan extenso, ¿no? en sus principios, y tiene un apartado precisamente de eso. No se trataba en este principio, no se trataba, pero sí se trata en el tercer principio. Entonces, es el hecho de crear redes, también hay un apartado de crear redes de colaboración para pues crear un recurso que sea accesible. La idea no es que el profesor al final de educación especial o el PT o el AL se englobe más en ayuda, ¿no?, al maestro, y entonces este diseño universal de aprendizaje junto con la inteligencia artificial pues va a permitir dotar a estos futuros maestros para que puedan llevar a cabo esa respuesta inclusiva, pero desde dentro del aula. Específicamente en relación a lo del aprendizaje colaborativo que comentabas, en este principio no se trabaja, pero sí se trabaja en el tercer principio, y bueno, al final es una totalidad que yo solo me he quedado con el segundo, sí, en el segundo principio, pero sí que se trabaja en el tercer principio, esa es la idea.
Gracias, Alba. En interés del tiempo vamos a pasar a la siguiente presentación ya, que es de Iván Sánchez López, de la Universitat Oberta de Cataluña, y está titulada AI and Storytelling, Creativity to Empower Vulnerable Communities Against Emerging Gaps. Mientras el presentador se prepara, hay un pequeño anuncio, y es que va a haber 4 comunicaciones en esta sesión. Va a haber una cuarta al final. ¿Vale?
Ahora, a ver, ¿qué más? Bueno, claro, porque a lo mejor no está mal. Tengo si no. De acuerdo. Bienvenidas, bienvenidos a esta presentación, como has dicho, AI en Storytelling, Creativity to Empower Vulnerability Communities Against Emerging Gaps. Yo soy Iván Sánchez López. Y lo que os voy a contar a continuación forma parte del marco del MAL, el Media Arts Lab, que es un proyecto financiado por la ayuda Ramón y Cajal y que tiene en consideración diferentes aspectos la narrativa digital, también las anomalías mediáticas y una rama específica de lo que llamaríamos AI Literacy, desarrollada en una doble vertiente. Por un lado, la investigación clásica, con metodologías más tradicionales, y por otra, el laboratorio. Un laboratorio de experimentación formal y también que tiene que ver con la inclusión digital. En concreto, hoy hablaremos del AI Storytelling, del laboratorio, digamos, de una línea de trabajo que se está desarrollando ahora mismo y que tiene una relación con toda esta explosión de recursos que nos ofrece la inteligencia artificial. Nos hablaba antes Alba, Alba nos hablaba de toda una serie de posibilidades de creación mediática, visual, textual que nos ofrecen los modelos de inteligencia artificial. En nuestro nuevo, no tan nuevo enfoque, queremos distanciarnos un poco del hype, ¿no?, de estos modelos, para evitar lo que denominaríamos el doble bucle epistemológico. Estamos acostumbrados, dentro de ciertos círculos académicos, a incurrir en esto de referencias, base teórica, imitación, tomar apuntes, reproducción, volcarlo en un examen y volver a las referencias. Esto no nos interesa tanto y de vez en cuando hay veces o la propia idiosincrasia de la inteligencia artificial nos puede llevar a una metareproducción de estos parámetros. Es decir, ella también funciona con referencias, con imitación y con reproducción, con lo cual queremos salirnos de este bucle para orientarnos a lo que podríamos decir, bueno, aquí he hecho este pequeño cambio conceptual donde la narrativa mediática, la narrativa se pone por delante de la inteligencia artificial y ahí sí incluimos el multimodal creativity to empower vulnerable communities against emerging gaps. Dicho esto, el enfoque que aplicamos se sale de la línea, vamos a decir, más vertical, de la educación más tradicional, para entrar en lo que llamaríamos un ritmo narrativo. Sí tenemos unas referencias y las aplicamos, y aquí hay un pequeño cambio. De las referencias base vamos a trabajar sobre el concepto de mímesis. Esto es Aristóteles, también es imitación, pero la idea es empezar a trabajar en un modelo mediático de tal conseguimos de esta manera coger ciertos skills, ciertas habilidades en el uso de las herramientas imitando a otros, y después sí, el gran diferencial sería el acto poético, la poiesis o la creatividad. ¿Qué nos permite la creatividad? Romper con la cuarta pared de los espacios de conocimiento, que en ocasiones son estancos, para pasar a nuestro objetivo, el objetivo de este proyecto, que es llegar a la agencia individual humana, a la comunidad, es decir, que el trabajo tenga una incidencia sobre la comunidad en la que nos movemos en función de nuestros parámetros y también una incidencia y transformación. En este sentido, en el futuro, nuestra intención es desarrollar este proyecto con una serie de comunidades que hemos detectado como vulnerables en el nuevo grupo de investigación. Hemos estado hablando y estamos haciendo una toma de contacto con el pueblo gitano, con personas de la tercera edad y también con menas, comunidades de menas en Barcelona, pero ahora específicamente hoy aquí voy a hablar de personas neurodivergentes. Y en concreto os voy a mostrar un trabajo realizado aquí en esta casa, en la Universidad de Alicante, en el grupo Hidu Edutikin, que se llama Prototipo, y que se desarrolló hace un par de años, ¿verdad, Andrés? Junto con la Asociación Aspali de Personas con Asperger en Alicante. Este es un programa modular. Aquí tenemos los 8 módulos básicos en los que la metodología es muy clara. Trabajamos en base a historias, trabajamos también formas, y el objetivo final de este proyecto es crear un elemento mediático a partir de los intereses de las y los participantes y que puedan tener esa agencia, esa incidencia y un trabajo sobre la comunidad. Aquí lo interesante de esta propuesta es que mezclamos, la base está en las historias, pero desde el principio ya estamos conjugando historias, formas y creación para que pueda haber un resultado con unas habilidades ya desarrolladas, ¿no? Y nuestra intención en nuestra nueva vía es integrar la inteligencia artificial en todos estos procesos. Aquí vemos como una estructura de proceso de trabajo, metodología muy clara y, vamos a decir, muy estructurada. Primero tenemos que saber lo que queremos contar. Voy a ir rápido. Después recogemos unas referencias e imitación posibles planteamos una estructura del proyecto, un plan de producción, plan de distribución y difusión y un plan de promoción. Una vez lo hemos abarcado todo, esto sería como una estructura clásica dentro de cualquier proyecto de mediaciones que queremos realizar, de mediaciones de carácter digital o audiovisual. Y por último hay una fase de ensayo y error. Todo esto te estará sonando, Andrés. Luego sabréis quién es Andrés para los que vienen del streaming, para los que nos están escuchando desde fuera. Y en todos estos procesos nos resulta interesante emplear recursos de inteligencia artificial. Aquí os he puesto algunos guiños, ¿no? Desde Stable Diffusion, Notebook LM para podcast, ChatGPT, revisión de guiones, incluso ampliación de contenidos, Midjourney y las novedades que incorpora la suite de Adobe. Aquí sí me parece importante resaltar que no trabajamos poniendo la inteligencia artificial en el núcleo del proyecto, sino que trabajamos con cámaras no estancas, ¿no? Lo primero que decidimos con los participantes del proyecto es qué historia quieren contar. Y a partir de ahí se ven atravesados por las formas. Cuando hablo de formas mediáticas, ahora cada vez hay más posibilidades, pero van desde el podcast a los vídeos musicales a incluso narrativa gráfica, ¿de acuerdo? Es ahí cuando tenemos determinada esa forma que tiene esa base humana de principio, que aplicamos la inteligencia artificial aprovechando al máximo los recursos. Ahí puede haber una interlocución entre inteligencia artificial y formas y contenido. Y después ya pasamos a la última fase, que sería la de creación. En la creación, de nuevo, nos interesa mucho poner el énfasis en que la creación es humana. Aquí no hablamos de co-creación, la IA es un recurso que utiliza el humano y, de nuevo, en el planteamiento de la creación nosotros estamos apuntando a la agencia de la comunidad y la incidencia de la transformación, y todo eso son, digamos que son dimensiones que vamos a trabajar desde el punto de vista humano y, en este caso, colectivo. ¿De acuerdo? Y voy a retomar, para cerrar esta intervención de alguna manera, el proyecto prototipo que realizamos hace un año y donde aplicábamos ya este rizoma narrativo. Para explicaros rápidamente, una de las fases del proyecto es enseñar el contexto y estereotipos mediáticos sobre las personas con las que estamos trabajando, y después ya hay un acto de creación. Os voy a poner un ejemplo real que les pusimos en los talleres a las personas neurodivergentes.
I met Sean Murphy when he was 14 years old.
Sean! Just act like a normal human being.
He was, and he still is, an extraordinary young man.
Autism. Difficulty in communicating.
He's high functioning. He's capable of living on his own.
Difficulty in using language and abstract concepts.
Lo he cortado en el momento de clímax. Bien, esta es una representación clásica, mediática, estereotipante, con claros rasgos hollywoodienses. Los pusimos en clase, tuvimos un debate sobre si había una representación, si se sentían representados con este tipo de persona que tiene el síndrome de Asperger, o lo que está dentro del espectro y que realmente es como superpoderoso en algunos aspectos, ¿no? Y a partir de ahí surgió esta idea interesante por parte del grupo con el que estábamos trabajando, que era crear su propia visión, o vamos a decir su propia versión, a través de una herramienta, vamos a decir, comunicacional, que es el documental. Os voy a poner un fragmento de Vivir con Asperger.
¿Ya? ¿Grabando?
A veces tú mismo a ti te dices como que no necesitas acomodación, pero sí que lo necesitas, porque como tema de luces, sonidos, estrés también, por ejemplo, y además también la gente muchas veces no sabe que tú eres autista, con lo cual no puedes hacer steaming, no te puedes autorregular, no hay espacios en los que puedas estar solo.
Hay características en el síndrome de Asperger que hacen que las personas tengan más déficit de atención o más obsesividad, que pueden desarrollar trastorno obsesivo-compulsivo, déficit de atención. Yo en mi caso tengo déficit de atención, pero igualmente puedo llevar los estudios.
Entonces fue la verdad que bastante difícil y tuve muchos meltdowns en todo el trabajo. Y entonces como que me iba al baño, estaba como a lo mejor 20 minutos así, llorando, poniéndome música a tope y salía y seguía trabajando. La verdad que fue muy traumático.
Algunas cosas pueden costar más de entender, algunos dobles sentidos, algunas cosas que para los demás son muy fáciles, luego hay que repetírselo al otro y a ti te preguntan, ¿no? ¿Has entendido? No, es que tengo dificultades.
Hay sinceramente mucha soledad porque obviamente tu familia no te va a entender porque ellos no tienen autismo, entonces a veces como, bueno, dentro de la familia te sientes como un poco fuera de lugar.
El principal problema es que no, desde la educación sobre todo, no se entienden las diferencias, no se aceptan, no se enseña a aceptar las diferencias.
Sí que siento que es verdad que aunque estemos en minoría ahora, el colectivo autista sí que está teniendo mucho más voz y creo que es muy importante que la voz se está dando desde dentro del propio colectivo, o sea, somos nosotros los que estamos haciendo el propio activismo, porque muchas veces lo hacían nuestros padres, lo hacían nuestros familiares, lo hacían nuestras parejas y al final la representación que teníamos era un poco errónea, era un poco idealizada, era un poco infantilizada y ahora sí que siento que se está viendo como mucha más presencia nuestra y la verdad que me gusta verlo porque también eso educa mucho a la población y hace que cada vez que conozcas a alguien y lo vayas diciendo le suene un poco más.
Resulta que hoy en día el tema del Asperger no está tan bien visto como se debería. He pensado, ¿y si se hace un vídeo en el cual nosotros, las personas con Asperger, pudiésemos dar nuestro, ¿cómo decirlo?, nuestro punto de vista para que así se dé como más brillo en la sociedad?
No sé si tenemos tiempo para hacerle una pregunta a Andrés, que es el... ¿Sí? Nada, muy rápido. Si quieres salir, Andrés, para las conclusiones. Claro, yo tenía preparadas mis conclusiones, pero ha podido venir uno de los directores, así que mejor que nos lo cuente él. Gracias por venir, Andrés. Nada. No, yo te quería preguntar, ¿qué es lo que te llevas del proyecto después de haberlo realizado? ¿Cuáles son tus sensaciones?
¿Lo puedes repetir con el micrófono?
Sí, por supuesto. ¿Qué sensaciones te quedan después de haber realizado el proyecto? ¿Cuáles crees tú que han sido los logros y qué destacarías después de todo el proceso?
Bueno, pues yo creo que lo básico es poder contar nuestra historia, nuestro punto de vista y que la gente pueda conocer más sobre nosotros, las personas con Asperger, desde nuestro punto de vista, lo principal. Darnos a conocer sobre todo y más, porque claro, la gente, como han dicho en el vídeo, se piensa que nuestro comportamiento es infantilizado, es todo muy básico, pero no, en verdad no. En verdad es todo con ganas de poder conquistar el mundo también nosotros. Eso es lo importante.
Muchas gracias, Andrés. Nada, si queréis ver el proyecto correcto... Un apunte solo, si queréis ver el proyecto íntegro, lo podéis encontrar en el canal de Andrés. Después lo pondremos para que podáis acceder. Gracias.
Gracias, Iván, por la presentación y por mostrar cómo las herramientas se pueden utilizar para contar historias que valen la pena. Pasamos a la siguiente presentación de Inma Abaortuño, de la Universidad de Lleida, que se titula A Comparative Analysis of Tools for Designing Chatbots in Higher Education Context. Just for reference, the presentation can be in Spanish or in English, as you prefer. Okay?
Well, I'm going to present in English, but later the question, if you prefer to ask in Spanish or English, whatever you want. I'm Inma Abaortuño, and I'm presenting this work that I did together with Victoria. Well, we are used to receive a lot of news during these last months and years about AI and AI in education. And we know that our students are interacting with these systems. And mainly with chatbots. They are using in their daily routines and in their learning activities. Furthermore, there are universities that are integrated these human-machine interactions in their web pages, and they have some open question chatbots in order to carry out tasks related with students' orientation here in different universities of Spain. Well, our students are used to interact with this technology, but the thing is that do they know how these chatbots work? Do they know what is behind this technology? Especially, do they know the mechanism and procedure these chatbots have in order to give you an answer? Normally, they are not related with what is behind, so we wanted to show students this reality, making them create their own chatbots. We developed this activity in the context of Universitat de Lleida, especially in the bachelor's degree of primary education, the minor of STEAM. And well, before starting with this activity, we did an analysis of tools in order to design chatbots. First, we created a spreadsheet with these different categories. We wanted to analyze if the app was easy to use, the personal data the students will be asked in order to use these tools, and the interaction, if they integrate generative AI, if they will be able to add images, voice, and other kind of information. Then we found 8 different tools. Each one of them was used in order to fill the different categories of the spreadsheet. In the category of usability, well, because of our context, we were looking for tools with low coding skills or no coding skill, because our students are not from the fire of engineering, but they are from the fire of education. But neither we wanted these kind of tools that are only based in prompting, because there are a lot of tools that you can make a prompt and they create a chatbot. We wanted the students to create the path of the language conversation. So here you can find the different characteristics of the tools in terms of usability. And then in terms of personal data, this was also important for us because we wanted to take care about the data of our students. So, of course, we don't want students to be asked for a credit card and this kind of stuff. So here you can find the kind of data you are asked when you have to log in, and meanwhile using the tools, etc. Well, finally, between all these 8 options, our choice was WordPress because of the kind of data you were asked, because you design the conversation and you link the different parts of the conversation. And also because you can work in groups, and this activity can be done with students in groups. Once we chose the tool, then we created a guide for these students to use this tool, and the guide is in Spanish and in Catalan. What else? In this Congress, the activity carried out with BotPress in Universidad of Lleida with these students I mentioned before has been also presented, but in the online conference. So you can find a video of my colleague Victoria talking about how students created their own chatbots. And as I said, if you have any question in English or Spanish, I'm here to try to answer. Thank you so much.
So we have time for questions. Any question from the audience?
Te pregunto ahora en español, Inma. Sí, yo aquí me gustaría preguntar cuál fue la principal dificultad que os encontrasteis con el desarrollo del proyecto, de la investigación, para con el trabajo de los estudiantes universitarios, que yo misma como profesora a veces me encuentro que no quieren mucho investigar o pensar en cosas nuevas.
Vale. Yo trabajé con Victoria en esta parte del análisis de las herramientas, pero la persona que ha llevado a cabo la actividad con los alumnos ha sido Victoria. Entonces, para darte una respuesta más concreta sobre el uso con los alumnos, las actividades o los pasos que ella ha seguido, te recomiendo que le preguntes a ella en el foro del Congreso. Imagino que estará atenta y si no, pues por correo. Porque yo no estuve presencialmente en el aula con los alumnos viendo cómo trabajaban. Sí.
Any other question from the audience? No. So I just have one. It's maybe it was asked before, but how hard is it for the students to learn how to use one of these tools, or for you to use one of these tools to create a meaningful chatbot?
Okay, I'm also for the background of primary education, so I have no experience programming, my skills coding are very low, and so on, as most of the students in this bachelor. You mean this specific tool or all the different ones?
Any of them, from the ones you evaluated, how difficult is it for them to create something that actually works?
Well, I found I tested all of them, but WordPress, I found it was easy because within the tool you have also at the beginning some steps to guide you and to learn. It's like linking nodes, and within the nodes you have different kind of cards. You can use cards of multiple options or generative AI, that this is more difficult, so it is a tool you can adapt to different levels. From my point of view, for students with no coding skill, the tool is quite well prepared for them. I don't know, as I said before, I don't know which difficulties the real students found. So if you want a more detailed answer, you can ask Victoria. Yeah.
Okay, thank you. Okay, we're going to the last presentation of this session, which is DeepSeer, un conjunto de datos para el reconocimiento del nivel de atención de alumnos en tiempo real, presentado por Sergio Suescun, de la Universidad de Alicante.
Muchas gracias, Germán. Bueno, ¿estamos? Yo soy Sergio Suescun y voy a presentar el proyecto DeepSeer, ¿vale? Como ha dicho Germán, un conjunto de datos para el reconocimiento del nivel de atención de estudiantes en tiempo real, ¿vale? Este trabajo forma parte del proyecto Prometeo MEDEVAI y está hecho con la colaboración de dos grupos de investigación, el grupo interdisciplinar, A ver, un momento. Grupo de investigación interdisciplinar en docencia universitaria, educación y tecnologías de la información y comunicación y educación inclusiva, que son los encargados de aportar los conocimientos de la parte en educación, y al grupo de robótica y visión tridimensional, que somos los encargados de aportar los conocimientos en la parte de informática y inteligencia artificial. ¿Vale? El objetivo de este proyecto es crear un conjunto de datos que sea capaz de aportar la información necesaria sobre el estado de una clase para que, utilizando técnicas de inteligencia artificial, seamos capaces de, en tiempo real, analizar cuál es el nivel de atención que están prestando los alumnos. ¿Vale? Para lograr grabar este dataset se ha adaptado un aula de la Escuela de Educación de la Universidad de Alicante, donde se han instalado el equipo necesario para grabar hasta un total de 20 alumnos. En cada sitio, en cada silla, digamos, por cada alumno se encuentra una cámara individual que capta información, o sea, que está orientada enfrente del alumno para poder tener una imagen central del alumno, y un reloj inteligente que los alumnos llevan puestos en la mano. Además de estas cámaras, hay repartidas a lo largo del aula cámaras de información de contexto, de información general, que son las encargadas de analizar en contexto de la clase, por ejemplo, dónde está situado el profesor, o poder ser capaz de reconocer qué actividades están realizando los alumnos. En cuanto a la información grabada en este conjunto de datos, tenemos, como ya he dicho, por un lado imágenes de estos dos tipos. Este es el tipo de imagen que captan las cámaras individuales, frontales, donde se ve en primer plano al alumno, y también tenemos las imágenes generales, ¿vale? Donde se puede ver perfectamente qué está realizando cada alumno. Además, cada participante cuenta con un reloj inteligente situado en su mano buena. Este reloj está capturando principalmente dos tipos de información: información inercial, es decir, qué movimientos están realizando los participantes. Por ejemplo, capturamos información del acelerómetro y el giroscopio, que miden movimiento, y el vector de rotación, que mide en qué posición está colocado el dispositivo. Además, también se captura información biométrica, en este caso, el ritmo cardíaco del participante. Adicionalmente, en este dataset se incluyen datos postprocesados, es decir, datos que no se han obtenido a la hora de grabar, sino que se han obtenido posteriormente analizando esta información con técnicas, en este caso, inteligencia artificial. En primer lugar, tenemos una IA que demuestra hacia dónde está mirando el usuario, es decir, la orientación de su cabeza, para saber, por ejemplo, si está mirando a la pizarra, al profesor, o está mirando a las musarañas, como se dice. Y en segundo lugar tenemos una IA que te muestra cuál es la postura corporal del participante, saber si está sentado erguido, saber si está así apoyado aburrido, ese tipo de información. ¿Vale? Para conseguir estos datos se ha utilizado este equipo de grabación. Tenemos un computador dedicado por cada dos estudiantes, que es el encargado de almacenar la información. La cámara simplemente está conectada por USB a este equipo, y todos los relojes inteligentes están conectados a su debido ordenador utilizando un router por una red Wi-Fi. En total, estos son los grupos que han participado en este conjunto de datos. Hay 3 grupos. 2 de ellos son de 20 participantes, que son estudiantes de grado. Y, por último, un tercer grupo con 16 participantes, que son estudiantes de máster. Tanto el grado como el máster son en educación. ¿Vale? Para grabar las actividades recogidas en este dataset hay 2 distribuciones de la clase. En la primera distribución, los 20 alumnos están orientados hacia la pizarra, ¿vale? Y utilizando esta distribución se han grabado las siguientes actividades. En primer lugar, una lectura de noticias. En este caso, los estudiantes pueden leer una serie de noticias, tanto de la pizarra, tanto del proyector donde se están proyectando, o utilizando cualquier dispositivo electrónico. En este caso no hay interacción del profesor, son los propios alumnos los que tienen que ellos, por su cuenta, leer las noticias. En la segunda actividad tenemos una lluvia de ideas, donde los estudiantes tienen que participar aportando sus propias ideas sobre las noticias que se acaban de leer. El tercer tipo de actividad grabada es la típica clase magistral, donde el profesor explica información sobre un determinado tema y no hay apenas participación o prácticamente nada participación de los estudiantes en la clase. En la siguiente actividad, los estudiantes deben organizar información. Se les aporta un tema y tienen que ellos mismos, utilizando Internet, recopilar información sobre el tema y sintetizarla. Y en la siguiente actividad que se grabó en el dataset es una prueba de lectura. En este caso, sobre la clase magistral que se hizo en la tercera actividad. O sea, en el mismo día donde se les dio la clase magistral, los alumnos tenían que hacer una prueba de lectura para ser capaces de demostrar cuánta información habían sido capaces de retener. Y la siguiente actividad es una presentación de trabajos individuales. En este caso, de los trabajos que los estudiantes hicieron recopilando información de Internet sobre la sintetización de información, se eligió al azar a uno de los estudiantes de cada grupo y se presentó la información que ese estudiante había recopilado. Y para el resto de actividades se utiliza la siguiente distribución. En este caso, los alumnos no están mirando la pizarra, sino que están enfrentes unos con otros. ¿Vale? Esto es para fomentar trabajos que se realizan en grupo. Con esta distribución se hizo primero una prueba de conocimiento donde se les evaluaba sobre contenidos que no habían visto ese mismo día, sino que habían visto en la clase anterior y se tenían que preparar, a diferencia de la otra prueba que era sobre contenidos que se habían visto en esa misma clase. Luego se realizó una experimentación en robótica, ¿vale? Se utilizaba el robot mTiny y los estudiantes utilizaban este robot para diseñar actividades que luego pudiesen realizar con sus futuros alumnos. No, perdona. Esta era la experimentar con el robot, aprender a utilizarlo, y la siguiente actividad ya era diseñar una actividad utilizando que involucrara al robot para que tuvieran que realizar los alumnos. ¿Vale? En cuanto al etiquetado del conjunto de datos, hay dos tipos de etiquetas, el nivel de atención y las emociones. El nivel de atención va del 1 al 5, siendo 1 el menor, la atención más baja, es decir, no está prestando nada de atención, y siendo 5 completa la atención más alta. Por el otro lado, en cuanto a las emociones, se han utilizado este conjunto: disfrute, esperanza, orgullo, alivio, ira, ansiedad, vergüenza, desesperanza y aburrimiento. Todos los datos del dataset están etiquetados tanto por los alumnos, es decir, autoetiquetados, se han etiquetado a sí mismos, como por una serie de expertos. Para fortalecer la validez de las etiquetas, se considera una etiqueta como buena cuando coincidía más de una vez la misma etiqueta sobre los mismos datos. Y con esto concluye mi presentación. Muchas gracias. Y por último, mencionar que este dataset está siendo publicado actualmente, ¿vale? Pero ya se puede acceder a él mediante un enlace privado, así que si hay cualquier interesado en acceder a estos datos, por favor que se ponga en contacto con algún miembro del equipo Robit. Muchas gracias.
Gracias, Sergio, por la presentación. Si alguien del público tiene preguntas.
Thank you so much for your presentation, and I'm sorry if I missed it because I was trying to catch up on the Spanish. So is one of the goals of your project to create teacher dashboards to provide feedback to the teachers based on the students' real-time learning data?
Yeah, yes. One of our main goals is to create an application that shows in real time the teacher the level of the average attention of the students. Imagine like a graph, like a continuous line that goes, now it's very high attention, now it's very low. So you can maybe not in the same session, but you want to compare between two different methods of teaching the same lesson, and you can, okay, this one is better, or this one is worse, because you can see the evolution of the attention.
Was there any other question from the audience?
Thank you. So I could understand a little bit, but my question is, so you have your labels at the end, the level of attention. How have you evaluated how you can predict those levels, or how do you get there? How you go from all of those devices, the webcam, the watch, to the level of attention of the student is 4, 5, or 3? How do you predict that, and how accurate are you at doing these predictions?
Okay, thank you for the question. In this project, it's only about creating the data set. It's not about using it to create the AI to predict the labels. We have some lines of investigation about that. For example, with information with a smartwatch, you can predict to make a classificator within some activities, like he's writing, he is using his mobile phone, and use this information later to classify between the different levels of attention. But for this project, it's only about the data set.
Yeah, Sergio, I'm going to repeat the question just out of curiosity. Well, I don't know.
Just to clarify this, the level of attention of the students in the data set has been labeled by humans, by a group of experts leveling this attention level. Yeah. No, not in real time. No. After the record, yeah.
It's good. Okay, so if there are no more questions, I hope you enjoyed the session and that you, by now, are convinced that AI can be helpful for us, not our enemy. And yeah, this finishes it. Thank you all the speakers, and thank you all.